Hey, welcome to The Numbers Game. I'm Coach T, and today we'll be going over derivatives. We'll specifically be looking at the chain rule and its applications. We'll go over how to identify a problem that requires the chain rule, how to apply the chain rule, and then we'll go through a few examples. Let's get started. The chain rule is used to find the derivative of a composite function. Now, a composite function looks like this. F of g of x. This is a composite function. We can usually identify a composite function by its parentheses. For instance, we may be given some function like 3 times 9x plus 1 squared. And here we see that we have stuff inside of the parentheses and we have stuff outside of the parentheses. So this is a composite function. The stuff inside of the parentheses, namely in this example, 9x plus 1, represents g. The stuff on the outside of the parentheses, namely 3, this coefficient, and the exponent 2, represent f. So thus we know we must use the chain rule to solve for the derivative of this function here. Now, the chain rule formula is if big F of x equals some composite function, so f of g of x, then the derivative equals f prime of g of x times g prime of x. Now, I know that looks super confusing and it's kind of hard to understand where to start. But basically what this means is we're going to find the derivative of the outside stuff, and then we're going to multiply it times the derivative of the inside stuff. Now, let's take a look at how to actually solve for the derivative of this example here. So we're going to take a little bit about what we know of the power rule, and we're going to solve for the derivative of the outside stuff first. So we'll bring the 2 to the front and multiply it times 3. We'll leave the stuff in the parentheses alone. So just rewrite it. And then we'll subtract 1 from 2. So we've got 2 minus 1 for that exponent. Next, we'll multiply this times the derivative of the stuff on the inside of the parentheses. So on the inside, we have 9x plus 1. The derivative of 9x is 9. And the derivative of 1 is 0. So we're multiplying 9 plus 0. Simplifying, 2 times 3 equals 6. Again, we'll leave the stuff inside of this parentheses alone. Then we have 2 minus 1, giving us an exponent of 1. And then we'll multiply times 9, because 9 plus 0 simply equals 9. Now this can be simplified one more time by multiplying 9 times 6, giving us 54. 9x plus 1. So this is our final answer. We were able to find that the derivative of 3 times 9x plus 1 squared equals 54 times 9x plus 1. Let's take a look at another example to truly understand the application of the chain rule. For this example, we'll take the derivative of 3x plus 2 raised to 5 plus x. Starting with the outside stuff, this exponent 5, and this x here, we'll bring the 5 to the front first. Leave the stuff in the parentheses alone. And then we'll subtract 1 from 5. Next, we'll find the derivative of x, which equals 1. And then next, we'll multiply all of this times the derivative of the stuff on the inside. So we've got 3x plus 2. The derivative of 3x equals 3, and the derivative of 2 equals 0. So here we've got 3 plus 0. Simplifying, we have 5 times 3x plus 2. 5 minus 1 equals 4 plus 1 times 3. Simplifying more, we have 5 times 3x plus 2 raised to 4 plus 1 times 3, which gives us 3. Now this here is our final answer. So we see that the derivative of 3x plus 2 raised to 5 plus x equals 5 times 3x plus 2 raised to 4 plus 3. Now let's take a look at one more example, and it'll be a trig example. So we'll find the derivative of sine squared of x. Now the chain rule can be applied to solve for trig functions such as this. So sine squared of x, we should note, equals the same as sine x squared. So given that we know this, we can use the chain rule to solve for the derivative of this. So if we're finding the derivative of sine of x squared, we have stuff on the inside of the parentheses, which is sine x, and then we have stuff on the outside of the parentheses, this exponent 2. We'll start by bringing the 2 to the front. 2. We'll leave the stuff inside the parentheses, sine x, alone. And then we'll say 2 minus 1. We'll multiply this time the derivative of the stuff in the inside. So here we have sine x, and the derivative of sine x equals cosine x. So this is time cosine x. So simplifying, we have 2 sine x. 2 minus 1 equals 1. And then time cosine x. This can be rewritten as 2 sine x time cosine x. This is our final answer. Our final answer, again, is 2 sine x times cosine x. So the derivative of sine squared of x equals 2 sine x times cosine x. Now, this is how we use the chain rule to be able to find the derivative of composite functions. Now, I'll leave you all with an example to do on your own. And once you find the answer, as I know you guys will, drop it down in the comments below. So take the derivative of x raised to the 4th plus 3x squared minus 9 raised to the 5th. Now, if this video was helpful, hit the like button and subscribe to our channel. Thank you for watching.